Well, good morning, good afternoon, or good evening, depending on where you are in the world visiting us today. My name is James Cantu. I am a program leader here with the University of Tennessee EHS and also the co-chair of the Professional Development Committee for SHEMA. On behalf of SHEMA, I'm happy to welcome you to today's presentation by Chemical Insights Research Institute. Chemicals Insights Research Institute, or CIRI, is a nonprofit 501c3 that promotes safe and healthy working, learning, and living environments through scientific insights. CIRI shares its research and knowledge through information and application tools to raise awareness of human health risks stemming from emerging technologies. CIRI is proud to be a strategic partner with SHEMA, where they can focus on delivering research findings to EHS and supporting professionals. In the past year, CIRI has participated in SHEMA's spring and fall symposiums, convened a working group on the safe use of 3DP in higher ed, and worked directly with SHEMA to deliver educational materials to their members. I would also like to remind you that we will be taking questions at the end, so please reserve those. However, you can put those in the chat in the meantime. Things that can be answered may be answered on the fly. Otherwise, we will reserve questions for the end. With that, I'll turn it over to Dr. Marilyn Black to begin today's presentation.
Thank you, James, for that nice introduction. Today, we're going to be talking about chemicals of concern that many of you are hearing about through various avenues and how they impact our buildings and what you might do as environmental health and safety managers to help mitigate any potential risk from those chemicals. I'm Marilyn. Nice to meet you. As James said, we are here as Chemical Insights Research Institute, which is an organization that's really researching primarily environmental pollution and its impact on public health. I have with me today Dr. Christy Bell Huff, who is CIRI's research manager, and we'll be working in tandem to lead you through this particular seminar. We've divided the seminar into different sections and expect to achieve these learning objectives. After the seminar today, we hope you'll be able to recognize and talk about the common types of air pollutants that are in our buildings, identify how they behave, what their sources are, and how to manage maintenance of their presence and their behavior in buildings, and understand the emerging risk and these particular chemicals of concern, and hopefully share with you resources that are available to help support healthy indoor air quality and healthy buildings. We've divided the seminar up into three parts. What's in our building air? What are some of the key chemicals, and how can you as managers help mitigate potential risk from these chemicals? And we're going to start with part one, and Christy will lead us through that. First of all, before we get started, though, I had these particular questions that I thought were relevant. I imagine some of you have heard them before. Is the air in the space healthy? What's that smell that I'm observing? Is this building making me sick? Is the air clean? I just heard about PFAS chemicals. What does that mean for us? So these are some of the types of questions that we get or we hear, and I imagine that you are too. So let's start talking about that. And Christy, if you can tell us what's in the air in our buildings.
Okay, I'm going to go ahead and turn my camera off so that the focus is mainly on the information. So now that you've seen us, thank you. Okay, so let's get started with our first section. And this is really where we'll lay the foundation for looking at what's in the air in our buildings. I mean, have you ever wished that you could kind of see what's in the air? I mean, maybe you haven't, but this is a scientific picture of what's actually in the air. And there can be anywhere between 200 and 1,000 chemicals in the air of our indoor environments at any one time. So this picture shows peaks, and each one of those peaks really represents a chemical that's in the air sample. This particular sample came from a LEED green building, and even so, it showed more than 450 VOCs in the indoor air. But what does that really look like in our actual spaces? So here's a typical office, and we can highlight some of those sources. For example, the carpeting might contain PFAS chemicals. The upholstered chairs, they might contain flame retardant chemicals. The cleaners that are being used might contain limonene, and the light fixture might contain phthalates. The MDF furniture could contain formaldehyde, and using the laser printer can produce styrene. And these are actually some of the specific chemicals that we're going to be discussing today. Now, as a safety and health professional, you might get a lot of questions about the chemicals that are in your spaces, and you might start asking yourself, do I have to remove all the chemicals from my space? I mean, how do I tell the occupants in my buildings that the air is safe? Well, of course, you don't have to remove all the chemicals, and you wouldn't be able to do that even if you wanted to, right? Because chemicals are literally everywhere. It's what stuff is made of. And many of the chemicals in our facilities, they come from the products that we use every day. And in fact, globally, there are 140,000 chemicals that are used to manufacture the products that we use on a daily basis. So in any given room, there's going to be a unique set of chemicals coming from a variety of sources. And just because the chemicals are there, that doesn't mean that they're all bad. And even if there are some certain chemicals of concern in your space, their presence alone isn't necessarily a problem. So the health risk actually depends on two factors. It depends on the pollutant's hazard, and by that we mean the inherent properties that can affect human health. It can also depend on the pollutant's exposure, meaning how much of the pollutant is present and for how long. So exposure could be short-term, and we would call that acute exposure. Or it might be of some kind of intermediate duration, semi-chronic. Or it could even be long-term chronic exposure. Now, exposure levels to a substance can also vary over the life of the product that they're contained in or the kind of material that they're contained in. So some materials might be more harmful during, say, the construction phase of your facility, or maybe during the disposal phase of the product. And a good example of that might be insulation and electrical wiring, because those will contain flame retardant chemicals. Now, those products are ultimately encapsulated in the wall, so they probably pose more of a potential risk to the installer rather than the building occupant. And health risks can actually vary across populations too. So there are some groups are more sensitive to exposure to indoor air pollutants than other groups. For example, pregnant women, children, the aging population, people who are immunocompromised, or maybe they're on drug therapies, and those who are chronically ill. And one thing to be aware of is that children are particularly vulnerable to harmful effects of exposure because they breathe faster than adults. So they can actually end up receiving higher doses in those smaller bodies. So having said all that, our goal is to take a strategic and informed approach to managing the chemicals in your spaces. And one of the first things that we need with so many chemicals out there, excuse me, we have to have some kind of organizing principle or way to think about the chemicals. So there are different ways that chemicals can be grouped. They might be grouped according to their uses, or they might be grouped according to their chemical structure. They might be grouped according to their physical properties or even their health effects. We're going to focus on a couple of classes of chemicals today, particularly volatile organic compounds, or VOCs, and semi-volatile organic compounds, or SVOCs. Now, indoor air can contain thousands of different kinds of pollutants, and that includes particulates, radon, allergens, other biological pollutants like mold, or even combustion gases. But today we are going to focus on VOCs and SVOCs because those are some of the primary concerns right now. But do keep in mind that when we get to the section on mitigation strategies, those strategies can apply across the board to all of these different indoor air pollutants. Okay, where are these chemicals coming from? Well, they can come from the products and the materials that we use in our facilities. They can come from the processes and activities that are going on there. They can even come from the people who bring chemicals with them when they walk in the door. Examples of products would include furnishings, furniture, equipment, and personal products. Examples of processes might include cleaning protocols that are going on. It could include the use of equipment like 3D printers and laser printers, and even just the various teaching and research activities that are happening in the buildings. And people, they bring chemicals in with their personal care products. Some people might actually bring in their own individual cleaning products. That's quite common. And they do even expel chemicals through their breath. So those are some of the sources of the chemicals, but let's talk briefly about how we actually get exposed. So we talk about 3 exposure routes: inhalation, like breathing, ingestion or through the mouth, and then also dermal absorption or through the skin. So these are important exposure routes that we have to consider, but it's also important to think about some of these chemicals that we're going to discuss today. In addition to becoming airborne, they can also settle into building dust, and they can get into materials like the carpeting, or they can settle on really any solid surface. So we do need to be thinking about airborne pollutants, but we also need to be thinking about what gets deposited on the environmental surfaces. And we will get into that when we get into the mitigation strategies later. Okay, so many people assume that if a product is for sale, that it's safe. Well, unfortunately, that's not necessarily the case. And the government has been regulating chemicals since about the 1970s. But at that time, they assumed that chemicals that were already in industrial use were safe. And that meant that 62,000 chemicals were grandfathered in without any safety testing. Now, there has been updated legislation passed since then in 2016, and that mandated that the EPA review the risks of these 62,000 chemicals. And since that law was passed, the EPA has completed their review of 3,692 of these. So some progress has been made, but we can't necessarily count on government regulation to ensure that every chemical in a product is safe. And actually, regulation, it often happens reactively instead of proactively. But we are seeing some shifts toward more proactive approaches to safeguarding, human health and well-being, and that's great. And I think similarly, we need to be taking a more proactive approach toward chemical safety as part of that trend. Now, another thing to think about, when you're looking at individual chemicals in an isolated lab study, that's not actually how real-world exposure works. So in an actual room, there's going to be dozens of sources of a variety of chemicals, right? So these chemicals are going to interact, they're going to form a complex mixture of pollutants that the people are going to be exposed to. They can react, they can interact, and often they do that in ways that we don't understand. So we really don't know how they behave when they're all mixed together. And this again kind of highlights the reason that we need to be more proactive about minimizing risks where we can. And the last thing I want to say for section 1 is that, of course, we want to reduce human exposure. Of course, we want to reduce negative health impacts, but we also kind of need to acknowledge how we got here. Manufacturers aren't just sitting around thinking about harmful things they can put in their products, right? Of course not. At some point, someone who was designing the product or developing the product, well, they thought using these chemicals in the product would serve a useful purpose. And some of these additives, they do make products more durable. Some of them can make products more flexible if that's needed. Some of them can make products stain resistant. Others can make products flame resistant. So all of those are important features, but there can be unintended consequences. And we really have to think about the trade-offs. But the good news is that we can find strategies to address this. So now I'm going to turn it over to Marilyn so she can discuss some of the key chemicals of concern that might be in our work environments and how we can be strategic about reducing or eliminating those chemicals.
Okay, thank you, Christy. That was a great overview. So let's talk about the specific chemicals of concern. And, as Christy said, there can be thousands of these different chemicals at one time. But today, we're going to focus on these specific ones because you're probably hearing about some of them. We're hearing about them. We're being asked questions. And also some of these are prolific in our buildings. And if we have a way of mitigating the levels of some of these buildings or eliminating them altogether from buildings, we will help manage our buildings for safer and healthier environments. So we're going to be talking about VOCs, specifically formaldehyde, styrene, and various terpenes, and some SVOCs that include the PFAS chemicals, flame retardants, and phthalates or plasticizers. So what is a VOC? Most of you probably know what a VOC is. It's a volatile organic compound, and obviously contains carbon. Many VOCs are present both in the indoor and outdoor air. But what makes volatile organics unique is just that they are volatile, meaning they can evaporate easily into the air at normal conditions. So they get into the air. Sometimes we know they're there because they have odors. Other times we don't know they're there, and they can be disguised as well as many of them. Now, health effects of VOCs have been pretty well established. It's been quite a while since we learned about the sick building syndrome back in the 1970s and what was causing that. That's when we really began the study of VOCs and understanding that there were so many in the indoor air. And we know the health effects of VOCs. We know primarily that kind of these mixtures of VOCs are really the source of a lot of what we call human irritation to the eye, ear, nose, and throat, respiratory symptoms, flu-like type diseases that can occur. But we also know that with more chronic type of exposure, that VOCs can lead to more serious health concerns, leading to organ damage, cardiovascular issues, central nervous system complaints, and long-term cancer for some of them. So health effects of VOCs are known, and we also have looked at the indoor air. And this particular slide comes from the digest of a series of air studies that were done by us in the past, looking at how do all those VOCs that we're finding fall into to what we consider the hazard classes from an indoor air standpoint. So typically, if you break down most of the VOCs that you'll find in the air, the pie chart will look like this. About 20% will be carcinogens, about 10 to 12% will be reproductive toxins, and the larger majority will fall into a classification called odorants and irritants, meaning we know that they're irritants. We may not have health information for more serious concerns from a long-term exposure. And we also know that some of them are odorants, meaning they have very low odor thresholds that can be very irritating to people. And then about 20 to 25% fall into what we consider that other category, where we really just don't know. We have very little information on them. So VOC behavior, what does that mean from an indoor air quality standpoint? VOCs, because they're volatile, they're in the air at all times. Because they're volatile and they're present, it also means that they can migrate into other materials. And we often find that other materials become secondary sources of VOCs that may have been released by another product. We know that VOCs are generally higher for newer products. So when you bring a new product into a building, generally those VOCs are high from a manufacturing perspective, but kind of decrease over time, and you can flush them out with good ventilation or airing the products out ahead of time. And again, we know that some of them have very low odor thresholds, which can mean you can have irritation in buildings. And, a couple of the types of VOCs where we have found odor to be a problem have been chemicals like 4-phenylcyclohexene, which is the new carpet odor. You can smell that in the air at around 10 parts per trillion. And some people find that very irritating, although the health data shows that it's really not a health hazard. The other one is phenol. We know that phenol has caused a lot of problems in buildings because of its low odor threshold. And phenol is often associated or a byproduct of plastic emissions and sometimes disinfectants. So that's kind of the way VOCs are. And the first key VOC I'm going to focus on is formaldehyde, again, which I'm sure many of you are very familiar with. Formaldehyde is the most prolifically found VOC in buildings and has been around for a large number of years. The good news is we've seen some reduction in formaldehyde in buildings. But you can always find it. It's in our buildings. Typically, if you have a normal building, you'll find it at levels around 20 to 40 micrograms per cubic meter. If you find levels higher than that, then it really is considered elevated. There are many sources of formaldehyde. Our composite wood products that contain things like medium density fiberboard, MDF, or particle board are our primary sources, but they're also found in textiles, construction, furnishing materials of all types. They're in combustion sources and often still used as a preservative in many of our consumer products. Now, formaldehyde itself is a carcinogen, and that has been established in our health studies, and why we have concern about its presence in the indoor environment. Now, one thing that a lot of people don't know is formaldehyde itself is also a very strong allergen. And a lot of the, about 8% of the US population actually has a contact allergy to formaldehyde. So if you have a product, say a textile that has a formaldehyde treatment on it, and a person puts their hand on their armchair, on the arm of their chair, and gets exposed to formaldehyde, they can have a dermal reaction to it. And that's a very common problem. And sometimes that reaction actually turns blue on a person's hand or skin. Now, one of the most famous case studies on formaldehyde was back during Hurricane Katrina, when when so many people had to be displaced from their homes. And FEMA, who thought they were doing a great thing, brought in all of these mobile trailers to put these displaced people. But within a couple of days of those people starting to inhabit these trailers, we had a pretty severe rash of reaction to being in them, where people started having respiratory issues, dermatitis from the allergen contact, and a number of things. And it was determined quickly through some fast studies that formaldehyde was really the big issue here, that the levels were extremely high, almost up to 1,000 micrograms per cubic meter that these people were being exposed to. And at the time, there wasn't a standard on allowable level of formaldehyde for materials. Fortunately, now we do have a national standard. The Formaldehyde Standards for Composite Wood Products Act of 2010 was signed into law in California that limits the amount of formaldehyde that can be released by a manufactured wood product. And in 2006, the EPA actually took that standard and codified it as a national standard. So all manufactured wood products now have to meet certain formaldehyde standards and be classified as to their contributions. So formaldehyde, pretty easy to measure. There are good measuring techniques for that out there, and there are even some sensors, real-time sensors that are available. The next key chemical I wanted to focus on is styrene. That is a very common VOC in buildings, and styrene obviously is associated with polystyrene plastics overall, and we have a lot of those plastics in our building, used in many of the materials that we use to furnish and design our buildings. But also we're finding that styrene is a pretty significant emission coming from our electronic equipment, very specifically our laser printers, photocopiers, 3D printers, and any sort of plastic fixture that we have. Styrene does have a sweet, obnoxious odor that people respond to very negatively. And typically you will find in a building at around 50 micrograms per cubic meter or less. Now, one thing that when we talk about indoor air, a lot of people don't realize that we really don't have regulated standards for acceptable levels of chemicals in the indoor air. We have OSHA standards for occupational environments, manufacturing environments, but not necessarily for the indoor air. It's something we have to keep in mind. The third group of VOCs I wanted to talk about were terpenes. These are things like limonene and pinene, which are solvents in their own right, but they're added to many products to not only give them solvent capability, but also fragrance. And I'm sure many of you are familiar with the lemon and lime smells. You often find them in cleaners, some personal care products. But these particular chemicals, because of their strong odors, do bring on a lot of complaints among people in buildings. And one of the most important things to realize is that these terpenes in a building will react with low levels of ozone, which comes in from the outdoor air traditionally, and all buildings will have a low level of ozone. But terpenes react with ozone to form ultrafine particles. And that actually is one of our strongest hazard concerns with the presence of these terpenes, and why we like to recommend that we focus on those and try to reduce them from buildings. So next, let's get into the semi-volatile organic compounds, or SVOCs. We've talked a lot about the VOCs, but the SVOCs are very similar. It just means that they are heavier types of organic compounds, which means they don't vaporize as rapidly into the indoor air. So you can end up with these SVOCs in the air. If they are in the air, it also means that they're there for a long period of time. Since they evaporate slowly from the products, they will continue to do that over an extended period of time. But one of the greater issues that we're seeing in buildings is that these SVOCs migrate out of their original source products, and then they settle on dust particles and end up in the building dust in our buildings. And that building dust can collect on any sort of surfaces, on a flooring surface, shelving surface, a furniture surface. It can get down into carpet if that's present, or any other porous materials. So once those SVOCs get into dust, then getting that dust out of buildings is requires a little bit more serious maintenance activity. Health effects of VOCs. Well, we have a lot of concern about the health effects of SVOCs. And we know that we can have some of the irritation and allergic type responses to them, but the bigger concern is that many of these SVOCs are stronger health concerns from primarily reproductive development. We know that many of them are endocrine disruptors, which means by doing so, and they get into the human body and they mimic hormones, that they can contribute to more serious issues such as learning disabilities, diabetes, obesity. Many of the SVOCs are now considered obesogens, meaning they lead to obesity and obviously reproductive issues relative to infertility. We've seen altered sperm counts among men and many types of issues associated with these. So a lot of concern. Now, I've already talked a little bit about the SVOC behavior, but they do migrate out of products because they're semi-volatile. They can condense on particles and that can then settle into buildings as dust to be there for a long time. And if they're present, they will off-gas for a long time. We've done studies on SVOCs coming off of products such as vinyl flooring, and we've taken vinyl flooring that's 10 years old, and you can still see some of the SVOCs, especially the phthalates, migrating off of that material. So introducing these SVOCs is not a good thing. One of the specific SVOC classifications I wanted to talk about were PFAS chemicals, because people are hearing a lot about PFAS in the marketplace right now. A lot of the discussion is on the presence of these specific chemicals in water systems because of their release from manufacturing or from airports that are using certain foams, that firefighting foams that contain PFAS. But These chemicals essentially are made of carbon and fluorine. The fact that the carbon fluorine bond is so strong, it means that they don't break up easily. And so when these chemicals get in our bodies or get into our environment, they're pretty much there today. And the studies being done by CDC are showing that over 90% of the US population has these PFAS chemicals in their body already. So they are known as pretty much for what we call forever chemicals, among some other chemicals. So some of the sources of PFAS chemicals, they obviously have been used a lot for soil and stain resist properties. And so you will find them in many of the furnishings in our buildings, the carpets and textiles, clothing. They obviously are present in nonstick cookware, paints, and many other products. You'll also find them in electrical wiring and coming from many plastic sorts of products. The next group of SVOCs that I wanted to talk about were flame retardants. Flame retardants also are one of those types of chemicals that stay in the environment for a long time, and some of them are known as forever chemicals as well. Flame retardants have been used for many years, starting back in 1967 when the Flammable Fabrics Act was enacted to manage the fire potential of many products like clothing, insulation, electronics. So many flame retardants have been used for many years, but the chemical structure and the chemical types of flame retardants have changed. We learned a while back that the halogenated flame retardants were of significant concern, and the industry voluntarily began to remove them. But we still see things like PBDEs. They will still be present in the environment occasionally. We'll still see them in products, but now we've moved more toward organonitrate, organophosphorus type flame retardants. And a big use of the flame retardants in our buildings has been traditionally in products that have the ability to ignite easily. And one of those has been furniture, which contains polyurethane foam as a padding. And polyurethane foam as a petrochemical, as you can imagine, is a pretty significant fuel source. And so high levels of flame retardants traditionally were added to polyurethane foam in furniture to manage the fire potentials. Now, if one wants to know if you've got products that contain flame retardants, Duke University runs a program where if you have mainly textile type products or foam and bedding or furniture, carpet cushion, things like that, you can actually send a piece of that foam to Duke, and under a program that they have with the EHS, they will test that and tell you whether it has flame retardants. And even today, about 50% of all the products that they're getting do still contain flame retardants. So there are many of them out there. So the third group I wanted to talk about were phthalates. These are essentially plasticizers that are added to many of our products to give them typically flexibility and performance type factors. Phthalates are very common in many products, anything PVC containing flooring, wiring, padding. We see them in a lot of office supplies. We're seeing them in kind of the popular artificial leather that's out there, a lot of personal care products. So there are numerous specific phthalates, but these phthalates are also very well established as endocrine disruptors that I talked about previously and are a significant concern from a human exposure standpoint. Now, I wanted to give you one case study of a residential long-term living environment that we worked with. In this particular community was built, and actually this was in the Atlanta area, and it was built a few years back, kind of positioned as we're really building to all the green standards. We're green, we're healthy, and that was a big marketing push for this particular group and filled up very rapidly because of that. But however, about 6 months in, the residents started complaining a lot about respiratory irritation, flu-like symptoms, and there was an observable odor in the facility. So we went in to do some studies to find out what was going on, and we did. And what did we find out? Well, we found that the formaldehyde levels were very high, that the formaldehyde levels were about 10 times higher than what you might typically find in a building. We found levels up to around 200 to 300 micrograms per cubic meter. We found the VOCs to be very elevated at about three times recommended levels, and we did observe a pungent odor. Of all the chemicals we measured, there were about 75 different chemicals that, when we ran across our hazard databases, that presented a concern. And some of those were formaldehyde, acetaldehyde, a series of glycols. We actually found mercury in the air and the subtle dust, ammonia, plasticizers, terpenes, some of the things we've been talking about today. Sources of those chemicals, there were lots of sources, but some of the primary sources we found, mercury was actually coming from the lighting, and that mercury was getting airborne and then settling onto dust, and then actually that dust was settling onto surfaces throughout the space. The glycols and acetaldehyde were originating from some of the spray foam insulation that was put into place. However, some of the highest levels of acetaldehyde were coming from the adhesive that was used to glue some of the flooring down. The space had used a cellulose insulation because it was deemed to be a very green type of insulation. However, it was treated with ammonia for flame retardant characteristics, but that ammonia was outgassing into the air. Formaldehyde sources were lots of pressed wood products used in shelving, cabinetry, and that type of thing. And the plasticizers that we found were actually coming from the light fixtures, and we believe it was just a form of plastic that had not been either formulated very well or cured very well, and allowing the plasticizers to emit once the light fixtures warmed up. So there were a lot of lessons to be learned. There were a lot of things that had to be fixed and redone in this building. But one of the things we learned to have people be aware of is that they were taken by the claims like, oh, these are natural products, generic products, alternative, they're VOC free, et cetera. And they really thought that they were getting the cream of the crop products, but it actually didn't mean very much. VOC free is a legal terminology that actually refers to manufacturing locations and the VOCs that they're releasing into the atmosphere, and whether or not they can participate in atmospheric reactions. It doesn't have anything to do with VOCs being emitted from products. So, our recommendation from these people to these people really was to make sure going forward that you use independent third-party certification of verification programs to qualify the products that you're bringing into buildings. So going from here, let's talk about what you can do as EHS managers to help mitigate these chemicals. Obviously, there are different ways, different strategies for managing the sources of these chemicals and managing the indoor air quality. And source control to us is one of the primary ways. If you never bring the sources into the building, you're not going to have an issue. But however, that's utopia, and that won't always be the source. Always the opportunity. You're going to have sources and chemicals in the building. So working with source control, we have to make sure that we have good ventilation, right? Good ventilation not only helps dilute and mix the air and flush some of the chemicals out, and that combined with good filtration. We have some good filters in the marketplace now that now have MERV ratings so that you can easily understand their filtration efficiency, and we recommend MERV 13 filters in most cases, if that can be achieved with the HVAC systems. So in addition to that, making sure that one has a good cleaning program in place with the right chemicals and the right processes, making sure that that cleaning process is effective, not just an aesthetic type of thing. And we also believe it's really important that we provide training to the occupants as well as the staff on all of these issues and what can make a difference. And bringing all that together into a facility management plan is a very strong thing to do. So I'd like to reiterate again that one of the most effective ways to minimize exposure to indoor pollutants is to prevent the emissions in the first place. And we've seen a lot of data showing that in general, the sources of emissions, if you qualify your products through some of the certification verification programs out there, we see pretty dramatic reductions in the presence of some of these chemicals in buildings. So what are the specific source control strategies that you can use? Obviously, as I was just saying, specify and buy the certified or verified low emission products. There are also a lot of chemical verification programs out there that address the composition of the products as well and have declarations around that. If you do bring buildings products in and you're concerned about the contributions they may make out, we recommend that you air them out before use, or if you bring them into the building, you air the building out before you allow the occupants to come in. Make sure in your specification requirements, you're requiring your vendors and suppliers to use these low emission chemical free products if possible. And last but not least, use the products as recommended and dispose of them safely. We still see many situations where people using, especially cleaning products, they think that more is better, and that's not the case. More will only introduce more chemicals into the space. So there are a lot of source control resources out there. There are a lot of independent third-party programs in the marketplace. And in today's world, these independent verified products economically are costing the same as those that are not qualified. So the economics don't come in the early days. Some of these products probably did cost more because it was unique in the marketplace, but today they're all available pretty much for the same price. So you just have to make sure you specify them. But these are some of the programs out there. There's the Green Screen program, which assesses all the chemicals in a product, and they have a list of safer products out there and a way to look at the products and the chemicals and what their health hazard is from kind of a red to green range. Then there are emission programs like UL Green Guard certification that address the VOC emissions from products. And then EPA has a number of greener product and services sort of resources available on their website that you can find and get a lot of information. The next thing I wanted to talk about a little bit was cleaning effectiveness, because cleaning is extremely important in the buildings and something that is oftentimes overlooked, or it's one of those things where the management doesn't want to put that much money into it, but in reality, it is extremely important. So I'd like to point out the key things. Practice good source control. Any sort of cleaning product, whether it's a disinfectant or a general cleaning product, needs to be one of those that has been approved by EPA Safer Chemical Program or other similar programs out there, making sure that it's free of the truly hazardous chemicals and is low emission. Vacuuming floors, textiles, furniture, making sure that good HEPA filtration is being used. Only use HEPA vacuums so that those vacuums can retain the small particulate dust that comes from many, many sources. And of course, I've talked about how that dust contains many of the semi-volatile organics and forever type chemicals we've been talking about. Make sure that when you're cleaning that you focus on kind of the high touch surfaces. We've learned that through the COVID process. your doorknobs and places where people are frequently putting their hands. And when you're using all these cleaners or disinfectants, making sure that you use them in well ventilated spaces, and if you can even open windows. And in buildings, we often see situations where the HVAC system is still being turned off at night, and then the cleaners come in to clean the building. Well, that's a real problem, because if there's no ventilation, then the emissions from that cleaning can't get out, and they end up absorbing into other materials and being in the building, and then create a big poop of chemicals when people come in the next day. We also recommend that you implement a routine cleaning program, and that's like cleaning on a routine schedule, not just when it looks dirty or when the cleaners can get there, but have a routine, because that really avoids the buildup of settled dust and films in particular that contain some of these hazardous semi-volatile organics we've talked about. I do have one brief case study on cleaning effectiveness. We did a study where we used two particular schools to look at comparing a routine cleaning program that was in place with a well-defined system that defined the specific cleaning chemicals to be used, the type of cleaning equipment to be used, the training of the cleaning professionals that were going to be doing this. And we compared a school that was using that sort of cleaning system with another school that was more periodic, where they cleaned the school when they thought they needed to clean the school, when they smelled something or it looked dirty and that type of thing. And they were not classifying or controlling the type of chemicals that were being brought into the school. They were allowing the cleaning folks that they were contracting with just to use whatever they had. And this actually was a year-long study where we went in and studied the air quality on a monthly basis. And we found a lot of interesting things in that study. And this particular slide just shows you the VOC levels 2 hours after cleaning. And you can see the high bar, which relates to the school that was using more traditional cleaners, decided by the cleaners, versus the school that had the prescribed low emission, low chemical cleaners. Very significant difference. The other thing that we looked at in this particular school were kind of markers that could show us if cleaning was actually making a difference. And these were three things that we studied: the absenteeism rate, the asthma medication being used by students, because that had to be registered in the schools, and the number of nurse visits that were happening for respiratory symptoms. And this particular chart just shows you the decrease in the numbers that were observed over an average two-week period in these schools. So pretty dramatic. And we actually had the one school talk about how it was so nice to not see these these asthma devices being brought in by students. They had seen a significant reduction in that. So very good information to show how important cleaning is. And last and not least, I want to talk a little bit about ventilation and filtration. Very important in buildings. A properly working HVAC system is extremely important, because it's not the sole fix, because you have to have source control as well, but it will help dilute pollution and transport them outside. Properly working HVAC system should incorporate about 15 to 20% outdoor air at all times. The air coming in needs to be filtered, preferably with MERV 13, or if that's not possible, MERV 11 filters. In some cases, depending on what's going on, you may even have to incorporate HEPA filtration in some specialized areas, especially in anything involved with healthcare. It's important to make sure that the ductwork is checked frequently for leaks or tears, so that you don't have loss of the air getting into the spaces. We believe that open plenums should not be used, and in new construction, they're not. But a lot of old buildings still use open plenums, and we really recommend that not only supply, but return vents and return systems have closed systems and not the open plenum. Another important factor is to make sure, because ventilation systems still are being turned off at night to preserve energy and cost. It's a cost issue, but we recommend that all buildings start running their HVAC systems at least 2 hours before occupancy, so that anything that's been building up in that space while the HVAC system's been off can be flushed out, and also making sure the HVAC system is running during cleaning and maintenance activities. I wanted to talk about a little bit about air cleaners, because everyone's been focused on using air cleaners, especially during COVID. We saw a significant increase in air cleaners in buildings. And there are air cleaners in the marketplace, some that are effective, especially in removing particulate matter. So what do you look for in a freestanding air cleaner? Well, first of all, you want to make sure it does have HEPA filtration. It's nice to have charcoal filtration, because that will help reduce some VOCs. But charcoal does get used very quickly, and so it would need to be, the charcoal filters need to be changed out pretty quickly and periodically, probably at least once a week. You want to make sure you bring in units that don't produce ozone, and California does have a regulation on this. So most air cleaners are not contributing ozone to the air today. And you want to make sure that you choose a unit that can clean a sufficient volume of the air. And we recommend that room units that are brought in are rated by AHAM, which is the American Home Appliance Manufacturers Organization, and they test these air cleaners and they give them a CADR, clean air delivery rate, and that you select a unit that's rated for at least 2/3 of the room's volume. And last but not least, make sure you have those ongoing maintenance activities taking place on the filtration. So overall, there's a lot of good information on filtration. ANSI ASHRAE 62.9.1 is the kind of the gold standard for ventilation for acceptable indoor air. EPA has a program called the EPA Clean Air and Buildings Challenge that you can find out about. And for standalone air cleaners, there's a lot of information out there. NIH has a good information on the selection and use of these. Harvard School of Public Health has some information, and they actually have a tool out on their site that allows you to calculate the amount of the CADR that you might need for your particular space. So that's some of the general guidelines available. And I do want to reiterate, because still people think that dilution is the solution for pollution, but I've seen, and we've seen many emitters of semi-volatile organics and organic chemicals in buildings where you just can't dilute them out. And the best thing to do is to manage those sources and minimize those sorts of sources from ever coming into your building. So those two things need to work together. Last but not least, I want to focus a little bit on occupant education and staff training, because this is really important, because people have a big impact on what's going on, and teaching occupants what they can do to help maintain good indoor air quality, even establish policies. And many schools and buildings have policies that restrict the chemicals, cleaning chemicals, fragrances, and things like that occupants can bring in. It's important to inform your occupants about your efforts, what you're doing, what they can do to obviously, report concerns and that type of thing. And we encourage you to encourage your occupants to report any IAQ issues, and that you follow up on it as quickly as you can. And don't assume there's not a problem, because somebody else's problem will become your problem very quickly. And I'm sure you've all experienced that as well. Also, train your facility staff on the protocols and best practices, the best that you can. And we find that most facilities are doing that by putting together what they consider a IAQ management plan that addresses the education and training required, response protocols, procurement, construction, renovations, maintenance, and all of those things. So something happened to my next slide. Is it coming? There it is. There's my management plan. So those are some of the key things, in addition to others that I'm sure you can think of needs to be in there. So that's pretty much what we had today to share with you. We've talked a lot about the basics of the chemicals. And these are some of the sources for those of you that want to look for some third-party sources on facility management plans and approaches that one might take. The whole building design guide I have found has a nice description of a sustainable operating and maintenance plan and practices. So today we've talked a lot about the basics about the chemicals and how to manage them and things you can do as a safety and health professional to help maintain good indoor air quality and hopefully make a environment that is safe and healthy for all that are present. So with that, I'd like to thank you very much for listening to Christy and I today, and hope you can take some of this knowledge and apply it in various ways, or hope you learn maybe a little bit new. You probably knew a lot of it, but we're more than happy to take any questions that you have.
All right.
Or you can also email us if you think of something afterwards, and we can either provide resources or information to help you.
All right. Thank you, Dr. Black and Dr. Bellhuff. We do have a couple of questions here. We're going to let this go for a couple of minutes to ask. First off, is there any equipment available that can test for different types of VOCs or SVOCs? They add, I think I only have used equipment that tests total VOCs, but can't differentiate between what VOC was detected.
Well, that's a great question. And, unfortunately, we don't have any economical, easy tools to use to get chemical differentiation. There's some analyzers out there that will give you total VOC indicators, so you can see whether you're high, low, and that type of thing. But generally, to really understand what these SVOCs and VOCs are, you have to collect discrete air samples and send them to a laboratory to get an analysis. There are some sensors that are starting to come out in the marketplace, and I mentioned that, and I'm sure you're all familiar with sensors for temperature, humidity, CO2, which works very well. But there's a good sensor. The good sensors are good now for PM 2.5 if you want to measure the small particles. The sensors are good for formaldehyde specifically, but in terms of covering TVOC or other specific chemicals, that's still in process.
All right, I think we'll squeeze in one more quick question here, and that was about mercury levels. What were the levels of mercury that was detected from the fluorescent bulbs? Were the bulbs intact and operational when they were emitting?
The bulbs were intact and operational. However, we suspect that there may have been some breakage of bulbs, maybe during the construction installation process. And that's a good question. Honestly, I cannot remember the specific mercury levels, but they were in the microgram per gram range, ppm range, relative to settled dust, and high enough to be of severe concern. So we had to bring in some strong remediation activities to get the mercury out of the building.
All right, with that, I think we will turn it over to Jackie perhaps to close us out. Thank you again, Dr. Black, Dr. Bellhuff.
Thank you.
Thank you.
Just a quick message for those who are asking. This webinar was recorded as well as the past SHEMA webinars. We are currently redesigning the SHEMA webinar archives on the website. So you will be receiving a formal email letting you know when those webinar archives are available. We have the IT specialists and graphic designers working on them. So stay tuned, they will be available soon. If anybody has any additional SHEMA related questions, you can send me an email. And then if Dr. Black and Christy want to make their emails available as well, you can reach out to them too if you have additional questions.